Hi, I'm Temitope Adeniji, and you're welcome to Organotope Chem Clinic, where chemistry becomes crystal clear. In this episode of Organic Chemistry, we are going to be talking about the IUPAC rules and naming of branch chain alkanes. We all know that hydrocarbons are subdivided into the aliphatic, alicyclic, and the aromatic hydrocarbon. The alkanes, they belong to the aliphatic group of hydrocarbon. Under the aliphatic hydrocarbon, we have the straight chain and the branch chain alkane. We've considered the nomenclature of the straight chain alkane in my previous video lesson entitled Hydrocarbons. In order to name the branch chain alkanes correctly, we are going to use the following rules as a guide. So our main focus in this video lesson is to name the branch chain alkanes. So we are going to be considering all the rules stated right here. Recall that when we discussed the hydrocarbons, we made mention of how the alkyl groups are derived from the alkane. The alkyl group, they are one hydrogen less compared to the alkane. Alkyl group has the general formula CnH2n plus 1, while the alkane has the general formula CnH2n plus 2. The first member of the alkane is the methane, as shown on the chart right here. The methane, which is the simplest member of the alkane homologous series, has the molecular formula CH4, while the ethane has the molecular formula C2H6 and the propane has the molecular formula C3H8. When one hydrogen atom is removed from the methane, it becomes what? CH3. That is alkyl group called the methyl group. When one hydrogen atom is removed from the ethane, it becomes the ethyl group. When one hydrogen atom is removed from the propane, we have the propyl group C3H7, as shown on the chart right here. So from methane we get the methyl, from ethane we get the ethyl, and from propane we get the propyl. They are one hydrogen less compared to the alkane members. Let us consider the first branch chain alkane right here. We've been asked to give the IUPAC nomenclature or name of this compound. So the first thing we need to understand is the rule 1. Identify the longest continuous carbon chain, which becomes the main chain. Now, when you consider this structure right here, the longest continuous carbon chain comprises of how many carbon atoms? When we go in this direction, we have 1, 2, 3, 4, 5. 5 carbon atoms in this direction. We can as well go in this direction, 1, 2, 3, 4, 5. 5 carbon atoms. So we've seen our longest continuous chain. It contains 5 carbon atoms in it. So I can indicate my longest continuous carbon chain in this direction. Okay? So the next thing we need to do is to consider rule 2. To specify the position of the side chain, assign number corresponding to their points of attachment on the main chain. Now, how do we assign the numbers? We move to rule 3. Carbon chain is numbered starting at the end nearest to the side chain. Now, how do we identify the end that is nearest to the side chain in this compound? So if we look at the concentration of the methyl group right here, we have this. We have another substituent group, and this is another substituent group. Here is the longest continuous carbon chain, which is the main chain. We can observe that we have more of the methyl group on this side of the chain than what we have on this side of the chain. So I'm going to consider the numbering. Moving back to rule 2 of the IUPAC nomenclature, let us assign the number since we've seen high concentration of the methyl group on this side of the chain. So we have carbon 1, 2, 3, 4, and 5. If we number the carbon chain in the other direction, it will be 1, 2, 3, 4, and 5. Note that the methyl group right here is found on carbon 2. If we consider the numbering in this direction, the methyl group will have 2, then another methyl group plus 2, then we have another methyl group right here plus 4. Okay, so on carbon 2 we have similar group, the methyl group on carbon 2, while another methyl group on carbon 4. Let us check the locants right here. The locants. Okay, if we consider the locants, we have 8. When we consider the numbering in this direction, we have a methyl group on carbon 2, another methyl group on carbon 4, and a methyl group on carbon 4. This gives us what? 10. And the rule says that we should assign the lowest locant to the substituent attached group. So we are going to consider the numbering in this direction. Make sense? We take the numbering in this direction. We can see our methyl group right here. We have the methyl group. Methyl group is found on carbon 2. We have another methyl group on carbon 2. Also, we have another methyl group on carbon 4. We separate the locants in IUPAC nomenclature with a comma. I mean the numbers that we have right here. You separate them with a comma. Okay, we have commas right here. And in between the number and alphabet, you indicate hyphen or a dash. But right here, we've been able to identify 3 locants. 1, 2, 3. So we move to rule 5. When the main group bears similar substituents, their location and number are represented by prefixing. When it is 2 similar substituents, you represent it with a di. When it is 3, tri. When it is 4, we have tetra. But right here, we have how many locants for the similar substituents? 1, 2, 3. So we have 3 similar substituents right here. So we use the prefix tri. Therefore, we have trimethyl. Okay, we are going to separate this. We are going to separate the number and the alphabet with hyphen or a dash. So all these represent the substituents group. Substituents group. Okay, which is at the prefix position of our nomenclature. The carbon skeleton comprises of 5 carbon atoms. 5 carbon atom is indicated with which word roots? Yes, that's correct. That's tense. Okay, so the word root for 5 carbon atom is tense. We have the word roots. Word roots. After the word roots, we identify the family name of this compound. Since we have single bond all through in this organic compound, it belongs to which homologous series? That's right, the alkane homologous series. So we have the alkane, ANE. The ANE right here indicates the suffix. So we have prefix, word root, suffix. So when you are naming organic compound, you need to consider the prefix, which is the substituent group, the word root, which is the carbon skeleton, the number of carbon atoms that we have in the main chain, and the suffix, which is the homologous series of the compound, that is the family of the compound that we are considering. So invariably, the IUPAC nomenclature of this compound right here is 2,2,4 trimethyl pentane. In naming this compound, we've adopted rule 1, which says identify the longest continuous carbon chain, and also rule 2, which says that we should identify the locant for the substituent group, that is the position of the substituents attached group. Then rule 3 says that we should start numbering from the side closer to the substituent group, but here we could identify similar substituents and we have higher concentration of the substituent on this side of the chain, so we started numbering from this side. Then we adopted rule 5 as well, which says that when we have similar substituents or multiple substituents that are identical, you are expected to indicate their number using the following prefix: di for 2, tri for 3, tetra for 4 similar substituents. Makes sense? Moving on, here we have another branch chain alkane. we have to name this compound right here. But the first thing we need to understand is the rule 1 says we should identify the longest continuous carbon chain. But right here, we can count the number of carbon here. 1, 2, 3, 4, 5, 6, 7. We have 7 right here. But if we go in this direction, we are going to be having group of substituents as attached group. And also right here, we are going to be having group of substituents as attached group if I should move in this direction. If I'm counting in this direction, I'll be having 1, 2, 3, 4, 5, 6, 7. 7 as well. This implies that we have competing chains. So we have to identify the main chain, because in this direction we have 1, 2, 3, 4, 5, 6, 7. 7 carbon atom in the main chain there. 1, 2, 3, 4, 5, 6, 7. 7 carbon atom. And I can also go in this direction. 1, 2, 3, 4, 5, 6, 7. 7 carbon atom. But in order to name this compound, I have to avoid the group of substituents right here. Isoalkyl group. We have another isoalkyl group right here. Okay. In order to avoid this and this, I have to take the numbering in this direction. Okay. So we have more of the substituents right here. I'm going to number this compound this way. 1, 2, 3, 4, 5, 6, 7. So I've been able to number the carbon skeleton or the main chain for this particular compound. Therefore, we have ethyl group right here. Then also we have another ethyl group right here. So these are similar substituents as stated in rule 5. Then we have methyl group right here on carbon 2. Also we have another methyl group right here on carbon 6, which is also similar substituents group. The next thing we need to do is to consider the arrangement of this nomenclature. Another rule that we need to adopt is rule 6. That is, we are expected to place the substituents in an alphabetical order. We have different substituents right here. We have a methyl group and ethyl group. In alphabetical order of arrangements, we are expected to have an ethyl before a methyl group. Okay, E comes before M. So that implies that if we follow our pattern of naming organic compound, the prefixes are, we have the ethyl and the methyl group. Okay, so the ethyl groups are found on carbon 3 and carbon 5. So we are going to say 3, 5. Okay. Then the methyl groups are found on carbon 2 and carbon 6. So I'm going to say 2, 6. Is that taken? Now, since we've identified 2 locants for this similar group, so for the ethyl, I will introduce the multiple prefix, the di. Okay? While for the methyl, I will also introduce the multiple prefix for the 2 locants, which is also di. So we have a diethyl and a dimethyl group right here. That is for the prefix, which indicates the substituent attached group. The next thing is to consider the word roots. The word roots indicates the number of carbon atoms in the organic compound. How many carbon atoms do we have? We have 7 carbon atoms in the main chain. So 7 is represented as what? Eps. That's good. So I have eps right here. Okay, which indicates 7 from the Latin way of numbering. Okay. Then the next thing we need to understand is what is the suffix of this particular compound. We have single bond alt group, therefore it belongs to what? Alkane homologous series. Can we bring all this together? The substituents group, which is the prefix, the eps, which is the parent name or the word root, and the suffix. We have the prefix, the word roots, and the suffix right here. So always remember that we use this pattern: prefix, word root, suffix. The prefix is the substituent attached group, the word root is the number of carbon atoms in the main chain, while the suffix is the family of the compound we are considering. So let's put this together. We have the nomenclature as 3. We have the nomenclature as 3,5-diethyl 2,6-dimethyl ethane. So the nomenclature is right here: 3,5-diethyl 2,6-dimethyl ethane. So here is the nomenclature of the organic compound right here. Make sense? I would like you to look at this structure right here closely, and you have to apply the following rules in order to name this structure correctly. We have several attached groups in this organic compound. So make sure you identify the main chain and indicate the substituent group at the prefix position. The number of carbon atom is represented by the word root, while the family of the compound is represented at the suffix position. I would like you to give the IUPAC nomenclature of this compound and drop your answers in the comment section below. So if you find this video lesson so interesting, kindly hit the subscribe button and share with your friends right now. You can also follow and like my Facebook page. Thanks for watching.